Good morning, everybody.
Morning.
I hereby open this academic ceremony in which Jean-Paul Kilroe will defend the academic thesis, The Impact of Short-Term Disuse and Dietary Protein Intake on Skeletal Muscle Mass and Protein Synthesis Rates in Humans. May I invite you to present a summary of your study and the conclusions of your thesis.
Thank you, Pro-Rector. Good morning, everyone. Thanks for coming. My name's Sean Kilroe, and I'm going to present my thesis, The Impact of Short-Term Disuse and Dietary Protein Intake on Skeletal Muscle Protein Synthesis Rates in Humans. So we know there's many factors that regulate the amount of muscle mass you have. There's two main ones. There's physical activity, and if you get enough physical activity per day, enough steps per day, that's going to maintain the muscle mass you have over the days and weeks. And if you get adequate nutrition, particularly at least 3 meals a day and enough protein ingestion in each meal, that's also going to maintain the amount of muscle mass you have over days and weeks. But if you remove either of physical activity or dietary intake, particularly protein ingestion, this is going to cause you to lose or reduce the amount of muscle mass you have. We know muscle is important, particularly in aging. You want to try and maintain the muscle mass you have to prevent diseases like sarcopenia and to maintain your strength and independence into old age. We know there's many causes of physical inactivity. It could be an injury at work or exercise. You could fracture your leg, and you might have to have a period of single leg immobilization via like a leg cast. And over time, this is going to result in a reduction in muscle size and strength. Or it could be more of an illness or medical condition where you might require a period of hospitalization. And again, if you're just laying down in bed all day and you're not using your muscles or contracting or walking around at all, this is also going to result in a reduction in muscle size and strength over time. We know the average length of stay in hospital for sort of mild conditions is around 7 days, so a lot of my work and previous research has focused on short-term periods of physical inactivity, like 1 week or less. A lot of previous research has investigated muscle atrophy after either bed rest or leg immobilization using CT scanning, as you can see in the image here. And this has been really good at detecting muscle atrophy in the major muscle groups of the leg, particularly the quadriceps, after short-term inactivity, 5 or 7 days. So it's a clear example of muscle atrophy during short-term inactivity. With CT scanning, you take a single image generally at the midpoint of the thigh, and you can calculate cross-sectional area changes, but you can't look at muscle volume changes or muscle mass changes using CT scanning typically. So in the first study, we employed MRI scanning, a different imaging technique where you can make multiple images along the length of the thigh, shown in the red lines here, and you can use those images to measure muscle volume at the major muscle groups, for example, the quadriceps or the thigh, and you can also look at how individual muscles, for example, on the bottom right here, the VL vastus lateralis, MRI scanning provides a resolution to see how these atrophy during inactivity. So in the first study, we wanted to characterize the time course response of individual thigh skeletal muscle mass and function during short-term single leg immobilization. So we had young, healthy males. They ambulated on crutches and wore a leg brace on one of their legs for 7 days. And we wanted to see over time, how did muscle atrophy occur? Did it decline steeply and then plateau, or was it a different atrophy rate? So the findings were that we could detect muscle atrophy in just 2 days in all the major muscle groups, the thigh, the quadriceps, and the hamstring. It was 1.7% in the thigh after 2 days, and this continued up to 7 days as well. So it's 5.5% in the thigh after 7 days. We saw that the quadriceps atrophied to a greater extent than the hamstring, and the loss of quadriceps muscle mass was more responsible for the overall thigh muscle loss compared to the hamstring muscle loss. The quadriceps atrophy contributed 60% to overall thigh loss after 7 days, hamstring just 10%. So this rapid decline in muscle atrophy highlights the need for any interventions that want to prevent or reduce muscle atrophy and loss of strength. These ideally need to start as soon as it's safe to do so, after the onset of atrophy, after the onset of disuse to try and prevent atrophy. And the difference between quadriceps and hamstring muscle loss means that for rehabilitation, strategies might try and use more quadriceps exercises rather than hamstring exercises to help recover that greater loss of quadriceps size and strength. For the individual muscles, these atrophied at differing rates after 2 and 7 days. So we had some muscles, for example, in green here, the sartorius and gracilis. These didn't atrophy at all after 7 days. Some of the hamstring muscles in yellow here, semitendinosus, these atrophied at around 0.5% per day. And some of the quadriceps muscles in red here, the vastus lateralis, these atrophied at nearly 1% per day. So there could be reasons for this. It could be genetic differences. Maybe there's certain genetic properties of the sartorius that might be different to other muscle groups that make them resistant to atrophy. Or it could be just the model of inactivity we used, where the leg brace was better able to immobilize quadriceps muscles compared to other muscle groups, or the habitual use of different muscle groups could also play a role in this. So we've looked at how the muscles atrophied, the quantity of atrophy, but we can also measure a bit more like why they're atrophying. So we measured also the synthesis, the muscle protein synthesis of the subjects during that week of immobilization as well. So we used a stabilized tote tracer called deuterium oxide, which is basically heavy water. It can bind to amino acids in the bloodstream, as shown in green here. These move into the muscle cell and then get incorporated into the muscle proteins. And via doing leg muscle biopsies in conjunction with the consumption of the heavy water, deuterium oxide, we can measure the rate of muscle protein synthesis. And it's like sort of a rate of muscle growth, and how does inactivity affect this? At the same time, like all tissues in the body, the muscle is also going to be breaking down. So you're always going to have this synthesis rate and the breakdown rate, which is going to rejuvenate muscle tissue. And it's these two things that are going to affect how much muscle mass you have. If synthesis and breakdown are the same, you're going to have this, over time, you're going to have the same muscle mass. But if synthesis is higher than breakdown over time, that's going to lead to a gain of muscle mass over time. So if we come back to our factors that regulate anabolic stimulation again, if we remove inactivity, or if we cause inactivity, how does this affect synthesis and breakdown and overall muscle mass? So in the first week of immobilization, or in that week of immobilization, the subjects also consumed the deuterium oxide, heavy water, and we wanted to look at how did muscle protein synthesis change over time. Again, how's the rate changing over time? We had biopsies before of both legs, before, after 2 and after 7 days of immobilization. We wanted to see how did muscle protein synthesis change over time during the inactivity. So the results were that the immobilized leg over the full week, the muscle protein synthesis rate was 36% lower in the immobilized leg than the control leg. And if we break this down over time, in the first 2 days, the immobilized leg in sort of red here in the graph was 16% lower than the control leg. And this does make sense, as we saw atrophy in those first 2 days. But if you look at the subsequent 5 days, the muscle protein synthesis rate in the immobilized leg was further reduced compared to the control leg, 44% of immobilization. 34% reduction in muscle protein synthesis rate, sorry. But how does this reduction in muscle protein synthesis, how can this explain the muscle atrophy we saw? So we saw, just to recap, a 6% lower muscle protein synthesis rate in the immobilized leg and the control leg, but this couldn't fully explain the 6.7% loss of quadriceps muscle mass over the full week of immobilization. From our calculations, this reduction could only explain around 47% to 50% of the reduction in quadriceps muscle size. So could it be that other factors are at play? Could it be that breakdown might increase and contribute to muscle protein the reduction in muscle size? Now, we didn't actually measure muscle protein breakdown. We did measure markers of breakdown, and certain genes involved in the breakdown of muscle proteins were more elevated in the immobilized leg than the control leg after 7 days. But future research needs to measure the muscle protein breakdown rate and see if this does contribute to atrophy. But there could be other factors that we made too many assumptions in our calculations that we assumed that muscle density doesn't change over time, or that vastus lateralis protein synthesis rates are equivalent to quadriceps protein synthesis rates. And some of these assumptions might also explain the loss of muscle atrophy. So if we come back to anabolic stimuli again and now focus on protein ingestion, we wanted to see how different types of protein might be used by the body, the bioavailability of different proteins, and how they might be digested and used as an anabolic source, basically. So we know that animal-based proteins like meat, like milk, are considered the gold standard. They're pretty high in most amino acids, or all amino acids, and they stimulate muscle protein synthesis rates and increase blood amino acids. But more recently, there's been a move to plant-based proteins, generally because they're slightly better for the environment. But sometimes these can be deficient in one or more amino acids. So we wanted to look at a fungal-based protein called mycoprotein and see how can this be used by the body, how is it digested, and does it increase blood amino acid levels after consumption. So the subjects came to the laboratory and they either consumed an animal-based protein, in this case milk, or the mycoprotein in different amounts. They had blood samples before and after, and we looked at the amino acid response to the different conditions. And we saw that you need the mycoprotein, 40 grams of mycoprotein elicited the same increase in branched chain amino acids and total amino acids compared to 20 grams of milk protein. So the mycoprotein could be digested and it would stimulate an increase in blood amino acid levels. And you needed around 40 grams of mycoprotein to match the same amount of milk protein. But the 40 grams of mycoprotein has a similar amount of total protein in the milk, as you can see on the left-hand side there, 18 grams to 16 grams. Mycoprotein has a lot of fibre in, which means the digestion and absorption of the amino acids was slower in the red circles, as you can see on the graph, compared to the milk in the white circles, which have far less fibre. So if we look at our anabolic stimuli again, if we remove activity but control nutrition during inactivity, how does this affect the balance of protein synthesis and protein breakdown and overall muscle mass loss during immobilization? So in the next study, we asked our subjects, young healthy males, to undergo 3 days of immobilization. And we gave them, there was 3 different groups, we gave them 3 different diets. So what we considered to be a good or an optimal protein intake, so 1.6 grams per kilogram, 28 grams per mil. And this was based on the first study. If you remember the first study, they lost 6.7% of quadriceps muscle mass, but they reported a high protein intake anyway, 1.6 grams per kilogram per day. So we were thinking, under normal conditions, around 20 to 25, 30 grams of protein just maximally stimulate muscle protein synthesis rates. So, but this wasn't able to prevent atrophy in that first study. But we tried to optimize it so they had the correct amount of protein per meal this time, 28 grams per meal, 3 meals a day and per 4 beds. Would this prevent the loss of muscle mass and function? We compared that to a second group that had 10 grams of protein per meal. And this is based on what's being reported in hospitalization settings, where maybe after surgery your appetite is lower. And is this reduced food intake contributing to muscle loss during hospitalization? And as a proof of concept to see if protein was doing anything at all, we tried to remove as much protein as possible from the diet. So the bottom group had 3 grams per meal. And we wanted to see, well, would this further exacerbate muscle loss during activity? Obviously, all 3 groups had the same total amount of calories. But despite the 3 groups consuming vastly different protein intakes, we still saw the same loss of quadriceps muscle size, and it was on average around 2.5%, as shown in the top graph here. And we still saw the same reduction in muscle protein synthesis rates, on average 28% per group. So despite the groups consuming totally different protein intakes, we still had the same reduction in muscle mass and muscle function also, and muscle protein synthesis rates. So in conclusion, the loss of muscle mass occurs rapidly after the onset of non-weight bearing. The rate of muscle protein synthesis declines rapidly after the onset of non-weight bearing and contributes but can't fully explain the muscle mass lost. Mycoprotein is a viable non-animal derived protein source, and protein intake doesn't, in our study at least, does not influence the amount of muscle strength or mass loss, nor declines in muscle protein synthesis rates during short-term immobilization. Thank you. I hand the word back to the pro-rector.
Thank you very much. A very clear summary of your thesis. The opposition will be opened by Professor Blaak, Professor of Human Biology at this university, and Professor Blaak was also chair of the assessment committee. Professor Blaak.
Thank you, Mr. Pro-Rector. Dear candidates, First, I would like to congratulate you with this very nice thesis, with a nice set of very controlled studies on the role of physical inactivity on muscle mass and protein synthesis. And of course, also congratulations to your promotion team. And of course, a very relevant topic with the increased sedentary lifestyle, but also very relevant for the older population, in particular during hospitalization. In most of your studies, you study healthy young males, and you already discussed that also very nicely in your general discussion. To what extent does that extrapolate to the whole population? For instance, to females, but also with respect to translation towards the older population when they get hospitalized, which may be a little bit more overweight or insulin resistance. So to start off, why did you choose for studying healthy young males? And secondly, would the results be different in the older population, which may be slightly insulin resistant?
Thank you, highly esteemed opponent, for the question. We chose young healthy males, I think more for practical reasons. They generally have greater muscle mass. So because we were studying short-term immobilization, we would be able to detect the loss of muscle mass using MRI scanning, as we saw. Whereas if we chose different populations, we maybe wouldn't been able to detect the muscle mass loss in the same time period. The males have more muscle mass, and they're generally going to it's easier to detect losses because they have more muscle mass, for example, than females. So that's why we chose males. And then to the second question, in older populations, what would be the situation, or overweight participants? I think there's some research that obviously older people, they have reduced or lower muscle mass than younger people. But there's been some arguments that the maybe rate of muscle loss is higher in older populations than lower populations or younger populations. So balancing those two factors out, either I think that older and the younger populations may lose the same amount during the same period of inactivity, or maybe that older people might lose slightly more muscle mass during short-term inactivity.
Okay, yes, very clear. But yeah, to expand a little bit on the mechanisms, when you specifically look at the overweight, insulin-resistant population, does insulin resistance impact also your protein muscle synthesis or your anabolic resistance? Or can you elaborate a little bit on that?
Yeah.
Does it do it, and what are the underlying mechanisms then?
Yeah, I think insulin does have a role in regulating muscle mass, and there's been some research that shows that insulin has a permissive role inhibiting muscle protein breakdown. So during inactivity, for example, if insulin was higher in certain groups, this may inhibit muscle protein breakdown and inhibit muscle. If it's higher, it maybe inhibit muscle protein breakdown and possibly reduce the muscle mass lost during inactivity. I'm not too sure about that. The older groups would definitely have anabolic resistance to protein ingestion. So, and again, this could contribute to why you can't stimulate muscle protein synthesis rates as much in the elderly or the overweight populations. If they have insulin resistance, maybe they have more like lipid deposition in the muscle, so they're more insulin resistant, and therefore the glucose uptake would be lower, but maybe this would also affect how muscle protein synthesis rates during inactivity as well.
Okay, yeah, I fully agree. Yeah, indeed, you refer to the lipid accumulation, and of course, when you have a little bit more overweight population, there are increased lipids in the circulation, possibly also increased inflammatory factors, and those factors may interfere then with anabolic resistance or the pathways?
Yeah, I think the inflammation, there's definitely a role of inflammation in muscle loss during inactivity, particularly with like NF-kappa beta signaling. If that pathway is upregulated, you might have an increase in muscle atrophy during immobilization. And if they're elderly, if they have more lipid in the muscle, if it's a more inflammatory situation inside the muscle, I'd expect that to affect muscle loss and potentially increase the amount of muscle loss during inactivity.
Okay, thank you very much. Just to proceed a little bit on the presence of different metabolic complications, not only anabolic resistance, but you also may have an impaired metabolic health in general. In that respect, I was very interested in chapter 4 also on the mycoprotein, because you indicate it's a good source of essential amino acids, it's more sustainable, but it also has broader health effects. So in that respect, in particular also in the elderly or metabolically compromised population, this may be a very good dietary strategy. Do you agree with that?
Yeah, I think it is a good dietary strategy for older populations or other populations as well. It's a good source of protein. It has a broad spectrum of amino acids. It's not really deficient in too many amino acids. It has quite a high fiber content as well, so when you consume the mycoprotein, it does have quite a good satiety effect, satiating effect, so it could help with maybe overweight populations, consumption of mycoprotein because of the high fiber content. There has been some evidence or there was previously speculation that consuming mycoprotein would increase sort of uric acid concentrations, but we don't really see that in our short-term study or other longer-term studies that Professor Wall has done in his group as well. So there was maybe some concerns about increasing uric acid concentrations, but I don't think these haven't been shown by more recent studies.
Okay, yeah, that's very clear. So health effects may be broader. Indeed, you indicate satiety. Yeah. Can you briefly indicate what could be the underlying mechanisms related to the satiety effects? Because you refer to that in your discussion. And perhaps first, what are the satiety effects? Because I missed the figure.
We didn't have a figure on satiety, but because, again, in the study we actually just studied healthy adult population, not necessarily elder population, but satiety was increased after the consumption, especially of the higher intakes of mycoprotein, like 40 and 60 grams of mycoprotein. I know that's sort of quite a lot to eat or consume. But yeah, satiety was increased after consumption, which if in middle-aged or older adults, if they are more overweight, maybe that could help in weight management.
And what could be the mechanisms for that?
It could be, I'm not too sure, I'm not an expert on satiety, but it could be like maybe a delayed gastric emptying, they feel fuller for longer. Again, I'm not hugely versed in this, but it could maybe stimulate GLP-1 and things like that that might affect satiety via a brain link, but I'm not really an expert.
And is that merely confined to the fiber effect or protein effect?
I think...
or perhaps both?
Yeah, perhaps both, but I think even protein intake alone would increase, if you had the correct amount of protein, the correct type of protein, that would increase satiety, and you'd perhaps see increase in certain molecular signaling proteins in the gut, like GLP-1, that maybe would reduce appetite just from protein alone.
Thank you very much. I'm very happy with the answers, and I give the word back to the prorector.
Thank you, Professor Blaak. Maybe I can ask you to go a little bit closer to the microphone, because the online connection, I'm not sure, but your co-supervisor is there. Yeah. The opposition will be continued by Professor Faber, Professor of Neuromuscular Disorders at this university. Professor Faber was also a member of the assessment committee. Professor Faber.
Thank you very much. Dear candidates, first I would also like to congratulate you with this important work, which is also very interesting for people working in a hospital setting like I do. And I would also like to congratulate your promotion team. First, I have a very general question, and it's about your introduction. You have there perfectly pointed out the relevance of maintenance of muscle mass as well as strength throughout life to reduce the prevalence of diseases like obesity and diabetes. This is also important in the light of the challenges we face in healthcare. I think it's in the UK, it's in the US and also in the Netherlands. Because we have an increasing demand in combination with a shortage in healthcare professionals. So we need to keep people as fit as possible.
Yeah.
You agree with that, I suppose, yes. Most people know that exercise and healthy food are very important, yet it seems very difficult to consistently change lifestyle, especially in groups with lower socioeconomic status. What should we do?
Dear highly esteemed opponent, thank you for the question. What strategies should we do to improve exercise and healthier nutrition in people from lower socio-economic backgrounds? I think it depends on the population, whether it be people who are elderly people or younger people, people who are healthy or people who are already maybe experience some sort of illness. I think in younger age groups to try and promote exercise and maybe healthy eating. I think that can start at home but also at school. I think a lot of schools now are trying to promote better nutrition in schools. They have a healthier, for example, lunchtime menu. I think that there's been big improvements in the UK to improve nutrition at lunchtime. We have those implementations like the healthy foods plate, where you need to be eating, or it recommends to eat a certain amount of fruit and vegetables per day, a certain amount of protein per meal and things like this. So I think that's a simple thing that younger children can understand. It's a visual aid that my plate should literally look like this. You should have this composition of vegetables, this composition of meat and things like that. So that's something that's good for, in terms of the nutrition of healthy people maybe in school. I think we should, in terms of maybe in those younger populations as well, encourage physical activity, make sure that physical education is on the curriculum at schools, offer students a broad range of choices when it comes to physical activity.
Yes, so if I understand correctly, your main strategy would be to start at younger age groups, children and young adults, to prevent problems later in life.
That would be one strategy, yeah. Definitely.
I think that's a good strategy. I have another question. In chapter 2, maybe one of the paronyms can read for me the proposition number 1.
Muscle atrophy develops well within 2 days of disuse and continues at a sustained rate over 1 week of leg immobilization in young, healthy males.
Thank you. For me, being a clinician, these results are translated in the shorter the immobilization, the better. Do you agree?
Yeah, I agree, yeah.
Okay. And if yes, how should we reach out to our hospital staff to have this implemented in more active mobilization schemes? Because that's then really important, I think.
Yeah. I think it's going to depend on the type of illness or medical condition or injury that any patient would have been hospitalized with. Sometimes it might be very difficult to implement activity if they're in intensive care or something like this. But where patients might be in hospital and they are able to move around, I think, yeah, it's important to communicate that to medical staff, the nurses, the occupational therapists, the physiotherapists. And that sort of education could maybe start in medical school to inform the future medical professionals that it's important to reduce the length of mobilisation as much as it's safe to do so. So that's how we can sort of increase the education of and awareness to try and promote activity. Maybe strategies to do that could be if the patient is able to, they could work with if the health professionals are able to implement more maybe game-based activities if the patient is able to. Just simple stuff like throwing and catching balls based on the age of the individual. It could be if they're able to walk to meal times rather than having meals in bed and things like this. So hopefully that's a way of educating medical professionals and implementation of physical activity as well.
Yeah. And we should also educate the patients as well, because what I discussed with your promoter, we see patients walking in the hospital and then they turn on their pajamas and go in the bed while they came in walking, and there's no reason to go into the bed. So that's something else we should do, maybe.
Yeah, definitely. I agree.
Yes. And then I have one last question. In chapter 5, you've studied the effect of protein intake on muscle protein synthesis. And, well, unfortunately, you did not see much of an effect. What does it mean? Does it mean that protein intake is not important? I don't think so. But what do you think?
Yeah, we were also a little bit surprised by the results. We saw because there was quite vastly different groups, we were surprised that there was no effect of the higher protein intake, at least reducing the mass loss or reduction in muscle protein synthesis rate. So we were surprised by that. I still think protein ingestion is important. After all, when you ingest proteins, they're broken down to amino acids, and amino acids are the building blocks of skeletal muscle. So you still need that fuel or source of the building blocks of muscle. You're always going to need protein ingestion, but one of the reasons maybe why we didn't see any effect of the protein ingestion could be that we needed to combine the protein ingestion with physical activities somehow. So maybe the muscle is only able to use those exogenous proteins from the diet when it's combined with exercise, or if there's a way to sensitize the muscle to the uptake or the anabolic properties of amino acids, we should also maybe try that too. And then maybe if we did try either of those strategies, the higher protein intake may have prevented the reduction in muscle mass and protein synthesis rates. But I still think protein ingestion is important, as it is the building blocks for skeletal muscle and other tissues.
Thank you very much. I'm satisfied with your answers, and I give the word back to the prorector.
Thank you, Professor Faber. The opposition will be continued by Professor Tsinsas, Professor of Human Physiology at the University of Nottingham Medical School and Queen's Medical Centre in Nottingham. And Professor Tsinsas was also a member of the assessment committee.
Thank you very much. Sean, thank you for your excellent presentation, and also congratulations to your supervisory promotion team. I just wanted to ask you a question about the use of MRI to assess muscle volume and mass. Obviously, it's regarded as a gold standard by most people. Are there any limitations to it?
I think that one of the things that when we were trying to measure the changes in muscle mass and how the reduction in muscle protein synthesis might contribute to that, like one of the assumptions we made is that muscle density wouldn't change. And that's something that isn't typically measured by MRI, or we didn't measure it by MRI. We could have measured it in the biopsies. There may be a way to look at water content via MRI, but because the water signal is so large from MRI, or the hydrogen signal from, there's so much water in muscle tissue that it's hard to measure the density changes, and that's one of the assumptions we made. So that's one of maybe the limitations of MRI.
Right. What about changes in intracellular water?
Yeah, that could have played a role in the changing in muscle density during our immobilization periods, and maybe have affected some of our calculations. I'm not sure. It's possible that maybe MRI scanning can differentiate between intracellular and extracellular fluid, but I'm not too sure on that. I'm not too sure if it can, to be honest.
Okay. So you show nice pictures of the decline in protein synthesis rate and muscle mass volume. You didn't mention too much about functional outcomes like strength, which actually decreased much more.
Yeah.
So if I was a devil's advocate, I would say, I would be interested in the functional outcome, which decreases much more, to 18-20% in strength.
Yeah.
And yet all the interventions are about minimizing muscle mass loss, which is not the biggest contributor to that decline in functional outcomes. So why is that? Why don't we focus, and what should we focus on? What other factors could explain that big change in functional outcomes and decrease in strength over a week, about 20% in 1 week?
Yeah.
How can we prevent that other than reducing muscle mass loss?
Yeah. I think maybe I should have presented some more, or had a more focus. Thanks, highly esteemed opponent again. I think I should have maybe presented more of the functional results, because as you say, I agree that we see a greater reduction in muscle strength, basically.
So what causes that other than the muscle mass loss? What other factors could be implicated?
Yeah, thanks. It could be changes in sort of muscle quality, where we don't just see a reduction in the quantity of muscle, maybe also a change and a reduction in the quality of muscle. As I sort of mentioned earlier, there could be like an increased lipid deposition in the muscle, and it's not going to be a contractile part of the muscle, so it's not going to produce force. And if there's more lipid in the muscle after immobilization, that would reduce the force or the strength of the muscle, especially compared to before immobilization. Obviously, it could be neuromuscular factors as well, where you're not able to stimulate the muscle from the central nervous system, from the brain to the muscle, so you get a reduced force output after immobilization, because the central nervous system can't stimulate the muscle as well as before immobilization.
So how can we actually then address this issue? What kind of interventions can we implement to?
Some of the interventions, depends if it's sort of more centrally focused or locally focused on the muscle. We could do, for example, like other people, like Luke has done and others have done, like electrical stimulation of the muscle. That's going to maintain the excitability of the muscle at the local level, at the muscle level, which should, I don't know for sure, I don't know if this work's been done, but I'd imagine that would help maintain sort of motor unit health and motor unit firing rates after immobilization. But that would be more local, and it depends if the reductions in neuromuscular function are more central from the muscle. If they're more central, then other interventions or additional interventions, not only electrical stimulation of the muscle, might also be beneficial.
Right, thank you. And just to follow up from a question from Professor Black, where you mentioned that you chose men because they had higher muscle mass to start with, and you'd expect greater changes. So are you implying that people with greater muscle mass will lose more lean body mass? Is that what you're trying to say?
In the work we saw, there was a correlation between the amount of muscle mass you had at pre-immobilization and the amount you lost. Like if you had greater muscle mass to start with, it correlated with losing more muscle mass during immobilization.
Right, so if that's the case, and it might be the case, it happens also in weight loss regimes, does this mean that an older person with less muscle mass will be less susceptible to immobilization?
Based on
Assuming they are not insulin resistant, they are healthy, not overweight, they have less muscle mass. So would it be less susceptible then, if that's the case, or what else could be implicated in aging?
I'm trying to think now. Yeah, there could be other factors may mean that the older person may lose the same or more, but I'm trying to sort of think of those off the bat. Yeah, it could be like the insulin resistance, it could be the anabolic resistance to protein ingestion and things like that.
Okay. And my final question is about the final chapter. I think it's the protein intake and the microprotein as well. So you mentioned that there's more fiber in it. And I think you gave it on its own without any other nutrients in your study. What happens in real life when you probably take it with some carbohydrates? What will be the implications for carbohydrate digestion and absorption?
I'd imagine that if you had the carbohydrates with the microprotein, you would get a reduced uptake of carbohydrates because of that protein, because of the fiber.
Right. And then the insulin responses may change if you co-ingest it with a meal? Yeah,
if you co-ingested it with a meal, the insulin, you'd expect maybe that because of slower or reduced absorption of carbohydrates, that the insulin response would be lower if you consume the microprotein with a carbohydrate source.
So would you advise somebody to take it on its own, or it's okay to take it with a meal? Mixed meal?
I think a mixed meal would be preferential if you're trying to maybe target some of those sort of health conditions like maybe the overweight or obesity. Microprotein mixed into with a full meal or mixed into the diet that could help reduce the carbohydrate uptake, which should be beneficial, or for type 2 diabetes would be beneficial, I think.
Great. Thank you very much, Sean. Thank you.
Thanks.
Well, thank you, Professor Tsinsas, and we will continue the opposition with Dr. Wittert. He is a senior lecturer in exercise metabolism and nutrition at King's College in London, and he was also a member of the assessment committee.
Thank you, Pro-Rector, and congratulations to Mr. PhD candidate for a very clear and confident presentation, and congratulations to the promotion team and to your family as well. I really enjoyed reading the thesis, and my first question relates to the model of muscle disuse that you used. You describe it as an uncomplicated model. And of course, you also set up the idea that there are also complicated scenarios of muscle disuse. So my question relates to how would you design a study moving forward that addresses a more complicated example of muscle disuse, and what additional measurements would you conduct in these types of studies?
Thank you, esteemed opponent, for the question. Yeah, I think when we were talking about uncomplicated and complicated, I think we were referring to other sort of health conditions that could also be present. In ours, we had healthy populations, so we termed that sort of uncomplicated. But in the future, to address or look at complicated disuse, we could there'd be multiple different study designs how we could address this, and factors that may predispose people to losing more or less muscle mass during disuse. So if someone had type 2 diabetes and if they were insulin resistant, it might be possible to, and I think studies are doing this now, doing bed rest, short-term bed rest in type 2 diabetics to see if that insulin resistance maybe would exacerbate the muscle loss during inactivity. So yeah, maybe a bed rest model in type 2 diabetics. If someone maybe had a more local injury, maybe like a leg fracture or knee replacement or along those lines, as we spoke about as well in the questions, that could be a model where inflammation may be increased. So maybe we could do, again, or the patients who maybe have a knee injury or ankle injury and have to undergo immobilization, that could be a good opportunity to not only look at the inactivity, but also sort of that complicated disuse where they may have greater inflammation that may cause more atrophy during disuse.
Thank you. And then for the next question, may I ask, sorry, I've forgotten what they're called, but...
Promoters?
Yeah, please, to read out number 3 of the propositions.
Muscle disuse atrophy is attributed to both an increase in muscle protein breakdown and a decrease in muscle protein synthesis.
So, in light of that statement, this is quite a controversial area within our field in terms of what is driving this muscle disuse. So, can you expand on that statement by perhaps explaining under which conditions may protein breakdown predominate? Which conditions may protein synthesis be the more dominant factor? It's a complex discussion, so can you just expand on that point, please?
There has been some, there's still a lot more to do in this this area of research, how protein synthesis and breakdown, how much they contribute to muscle atrophy. There has been some work during short-term immobilization, really, in young healthy males that Professor Wall did, where they didn't see an increase in breakdown, and that's sort of in an uncomplicated model as well. So it could be that in uncomplicated models where the participants or subjects are healthy, that muscle protein breakdown isn't much of a factor. It could be in more complicated models where other health conditions may be prevalent, like, as we were mentioning, after surgery, perhaps, where there's a greater inflammatory situation within the muscle. Under that situation, there might be an increase in muscle protein breakdown that contributes to muscle loss during atrophy. So, but it depends on, there's a lot more work to do. It depends on the time of immobilization as well. And how short-term immobilization might be more protein synthesis or both protein synthesis and breakdown, but over time this may change, where breakdown is more or less influential after longer-term immobilization, like 2 weeks.
Thank you. And I thought one of the strengths of your thesis was the utilization of the deuterium oxide tracer methodology for measuring free living rates of muscle protein synthesis. But my question is more of a devil's advocate question in relation to the more traditional acute infusion type tracer methodologies. Do you think that there's a place for those types of methods moving forward in our field? Or do you think that they're now old news and kind of defunct? Can you think of different situations in which those acute infusion trials are actually provide us with useful information?
Yeah. In terms of just disuse, or
it can be beyond disuse.
Okay, no, I still think the acute stabilized type infusions definitely have a place moving forwards. I think there's a role for both moving forwards. As we were saying, the deuterium oxide allows for more sort of free living conditions. There has been some research that suggests that you can detect changes in protein synthesis after a meal with deuterium oxide, and that might lessen the argument for using acute stabilized type tracer infusions. But the tradition and history of the acute stabilized type tracers have been applied to a lot more research questions. Using deuterium oxide to measure sort of muscle protein breakdown will still be quite difficult, I believe, and the more traditional tracers might be more beneficial in that situation. So I think there's definitely a room for both, whether it being sort of looking at muscle protein synthesis or lipid or carbohydrate synthesis and stuff like that. Although obviously deuterium oxide can be used to some fashion to measure lipid and carbohydrate metabolism as well.
Thank you very much, Mr. PhD candidate, and very happy with the responses to my questions. And I'll hand back to the Pro-Rector.
Thank you very much, Dr. Wittert. The opposition will be continued by Professor Jonkers. She is Professor of Intestinal Health at this university. She was member of the assessment committee and is also secretary of this committee.
Thank you very much. Also, dear candidate, also I would like to congratulate you and your supervisory team with a very interesting thesis. I read it with great pleasure. I also learned a lot. I'm a professor of intestinal health, so it's already a little bit in the name, not into the muscle health. So it was very interesting, and I tried to see what I can pick out of this thesis and learn from that. So I would like to follow up on some of the points already a bit addressed. But first, would like to go to chapter 3, where you see this 1.7% decrease in muscle volume and 5.5% after 7 days. And then I read that you found a 36% decrease in the protein synthesis rate. And then in the beginning I thought, okay, I don't have to worry too much because then only 5.5% was loss in volume. So, but I didn't understand if there's about 1/3 decrease in protein synthesis, why only then such a minor decrease in muscle volume? Can you explain that to me?
Yeah, thank you, highly esteemed opponent, for the question. This is something we thought about quite a lot during the work we were carrying out, and the other people in the field have sort of grappled with as well. When we're measuring sort of muscle mass or tissue mass or leg muscle mass, we're measuring a changing the size of the muscle. Generally, it changes a slower rate, but we're measuring muscle tissue there. Whereas when we apply the deuterium oxide tracer to measure muscle protein synthesis rates, we're measuring a rate of a cellular process. So these changes in cellular processes, like the rate of muscle protein synthesis, although it declined 36% and the muscle only 5.5%, we're measuring two different things. One's the size of a muscle or muscle tissue, and one's the rate of a cellular process. And the cellular processes change a lot throughout the day. They're sort of more diurnal in nature or daily in nature. Sometimes they can increase a lot, sometimes they can decrease a lot. But muscle tissue takes longer to change. So we're measuring two different things. So just because we get a big decrease in muscle protein synthesis, it doesn't mean we're also going to get such a large decrease in muscle mass.
Yeah, I understand it's not that simple as I thought it would be. It's not such a simple one-on-one relationship. And that's what I also noticed if I look to the fact that you also collected biopsy samples. I really like the combination of techniques you use, you know. I think that's really a very nice translational approach. And then you indeed saw this increase in gene expression on the ubiquitin proteasome-mediated breakdown after 7 days, but not after 2 days. And then I still a bit struggled. What happens after 2 days then? How come that you still see this effect? Can you? Because I thought, okay, gene expression reacts quite fast normally, even sometimes, instantly or within hours. And then I really had expected to see an effect there. Yeah. Did you also?
Yeah, we thought, from previous research, we did think that when we measured markers or the gene expression of the muscle protein breakdown, when we measured the genetic expression of those genes, we, along with other research, thought that this might happen quite early in after the onset of inactivity, after just 2 or 3 days. That's what some other researchers reported. But we felt it was more, so we were a little bit surprised it was 7 days, and I agree that sometimes gene expression can be a fast process, the translation of certain genes, but because of the model we were using and the metabolic and the physical changes in muscle tissue, we see a small change after 2 days, but a greater change after 7 days. So we thought that because of the stimulation we are using, muscle disuse, and the slow change in muscle mass, or the relatively slow change in muscle mass over time, we thought it was more of a response to the I guess, slower response in muscle mass, if that makes sense.
And could it be due to the fact that you had this well-trained, because felt a little bit that you had very sporty, healthy young men there, that they are very well-trained and with already a very high protein intake beforehand? Could that be one of the reasons that you could not pick it up at 2 days, maybe?
Yeah. I think if we had more sedentary participants, or if they were more elderly participants who weren't as physically active, whose protein ingestion wasn't as high, then maybe we could have saw an increase in muscle protein breakdown after those 2 days. So I agree that other factors could have played into us not seeing that response.
Okay, thank you. And then I would like to move on to chapter 4, because I also was quite intrigued by your protein intervention study there, the mycoprotein versus the milk protein. It already has been touched upon a little bit. And also the role of food, the combination with carbohydrates. But I was thinking, okay, this mycoprotein, they make the corn burgers of it. So normally you bake them as you eat them. So why did you not use a baked form of your protein? Did you consider that, or what would you expect then?
When we were working on this project, it was still this is one of the first studies who looked at mycoprotein and the digestion and absorption of, and if it would increase amino acids post-absorption. It was one of the very early studies on this, or maybe the first study on this. So at that time, we were just we wanted to identify if the mycoprotein could be ingested and consumed and absorbed by the body, and would it increase amino acid levels? But I think future work, and that's definitely something we would expect it as well if we had have cooked the mycoprotein or in different
and what would you expect if you would have a burger of this corn protein? Corn burger. What would you expect? Would it be a different outcome?
I think if because possibly you've cooked the meal, you've maybe heated the food source, and you've maybe denatured or broken down some of the proteins in the mycoprotein. So it could be possible that it would be slightly faster absorption, although you still have the fiber, the fiber of the mycoprotein there.
Yeah, I was really intrigued by this mycoproteins because I already mentioned I work on intestinal health, so the patients with chronic inflammatory diseases like Crohn's disease or ulcerative colitis, if they have severe disease, they often are hospitalized, sometimes even a few times, during or several times during their life, because it's a chronic disease. Yeah. And then I saw also that you wrote that there's an additive effect if there's more often periods of this disuse. Should we be worried in these patients who have more often had a hospitalization in the past? Should we check on their muscle protein, their muscle quality, volume? What do you think? What should you advise us?
I think, there has been some theories that if you have sort of repeated, as you suggested, those repeated hospital visits or those repeated, hospital visits where you have those repeated periods of inactivity, there has been some idea or speculation that this would lead to a greater or quicker loss of muscle mass after sort of 3, 4, or 5 times.
Yeah, how could that work? How could that be additive? Do you have any idea?
I think it could be the fact that post-hospitalization, as you're saying, maybe we should check the volume and quality of the muscle, because if we do the patients have the same muscle mass when they leave hospital compared to when they came to hospital, if they leave hospital with a lower muscle mass than when they came with, over time, if they continue with a sedentary lifestyle and then undergo another period of hospitalization, they may never have had a chance to regain the full muscle mass and strength they had prior to any hospitalization. So I think that's sort of how it might be additive, that they have one period of hospitalisation, they leave, which reduces their muscle size and strength. They leave hospital where they haven't fully recovered or rehabilitated all the muscle size and strength. And then if they're not physically active or active enough, they don't fully regain the muscle strength they had before the first period of hospitalisation. They have a second period, and then it sort of might be an additive effect where you lose muscle.
Yeah, so it's good for us to be aware of that. And does it matter, do we have to take into account the degree of inflammation they have, do you think?
Yeah, I think that could definitely play a role in losing muscle mass during hospitalisation or during other forms of physical inactivity. Yeah, if we... I think there's still work to be done here, but between the status of information within a person, how much muscle mass you lose, but yeah, I think maybe longitudinal studies or maybe hospitalisation studies where you can recruit a lot more participants, and maybe make some of those associations between some of the inflammatory markers and muscle mass before and after hospitalisation. I think that could be something really interesting moving forward.
Yeah, certainly very interesting. And would you advise to me to give them then microprotein or milk protein? What should I for this patient group?
For the patients who have altered gut health, or
which have a low-grade inflammation also, and also have to be hospitalised quite often.
I think.
You can.
I think there's still more work.
You can briefly answer the question if you like, but you can also say, Fuzina.
I think there's more work to do with mycoprotein in patient groups. I'm not aware of too many studies where they've provided mycoprotein to hospitalised patients, but I think it's an avenue, a interesting, exciting avenue for future research. I think hospitals as well have to be aware of the sources of food they're getting, if it's environmentally friendly, and if it's going to be also healthy and beneficial to some patient groups. Yeah, but I think future work needs to be done on mycoprotein and some patient groups.
Thank you very much. I give the word back to the prorector.
Well, thank you very much, Professor Jonkers. Sean Kilroe, the time appointed for defending your thesis has passed. The degree committee will now withdraw to discuss the quality of your thesis and your defense. I request you and your company to await the results of our deliberations and our return in this room.
Please all rise.
The PhD defense has now ended. The degree committee will debate the candidate's performance behind closed doors. This process usually takes about 10 minutes.
Long road to the south side. 7 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and die. I know you know that I can't read your mind. Years can't fly by now, don't waste all your time. Cause I'll go the extra mile. Long road road to the south side, 7 miles in my rearview mirror. I know what it felt like. My goal's only getting clearer. East side to the west side, no place like home. If it's questions that you've got, go the extra mile and die. On the dash, got my laces tied. Long road, I don't waste no time. Break rules because fate decides. With the team and we chase the light. I make a move, fall down, shake it off. I hate to lose, bad branch, break it off. No room for negativity, praise and love. Prepare for deep part cause we're taking off. Take the mileage, traveling so far from home. Gathering knowledge, other connections. I put the time in to get everything I ever hoped for. It's a challenge and we all in. It's a better future that we go for. And even though these nights seem long, I know that I am never on my own. Know you've won the battle once you've grown. Long road to the south side, 7 miles in my rearview mirror. I know what it felt like. My goal's only getting clearer. East side to the west side, no place like home. If it's questions that you've got, go the extra mile and die. Long road to the south side, 7 miles in my rearview mirror. I know what it felt like. My goal's only getting clearer. East side to the west side, no place like home. If it's questions that you've got, go the extra mile and die. What's on the line? I know you know that I can't read your mind. Years can't fly by now, don't waste all your time. Cause I'll go the extra mile.
And she turns the video off again.
Yes. Chinese, you also like, we need to like the question, can you give some remarks on that? Very nice, yeah, thank you. Thank you all. Hey man, wat kan er maken? But like, everybody here has, except for Kostas, has like a second agenda of getting his degree. It's like, they'll have the department which he promotes. There's the director of the head of all the departments. Then there's Kostas, who's also like collaborating with them. I don't know him. Yeah, so it's like, it's not like everybody says no. No. I think it happened once, but I'm not sure. I know that.
But not here in Maastricht. I think it was at a different university, and then there was this big.
No, but there was within the department, and one of the profs was in the Corona, and they had like a score to settle with the promoter. So, yeah. So he started asking questions, but like completely trying to destroy the both candidate. Yeah. I think if you only fail if you can't give a presentation and fail to answer the questions. So even though someone who had like fainted or something.
Yeah, I heard that as well during the presentation.
Yeah.
That can happen though, right?
Yeah, but it was like it wasn't like of nerves. It was some, like a medical issue.
Stress doesn't help with triggers.
No.
Doesn't help at all. Doesn't help at all.
For some reason, when I was up there, I did not see and like the lights.
And now you're almost falling asleep, weren't you?
Yeah, no.
Yeah, in the beginning it's like.
No, it's the game. You're trying to sense it.
Yeah, exactly.
I also had like this.
Yeah, but I have like a knee injury and this knee doesn't go straight. So I was thinking about it.
Doesn't go straight?
Back and forth. It doesn't straight. So it's like technically shorter than my other leg.
Oh yeah?
It really forced it straight.
The meniscus is smaller, longer. No, shorter.
There's no meniscus.
There's no
And
meniscus.
there's all scar tissue.
Oh, that's the issue.
Yeah, I had ACL surgery and the surgeon was like, oh yeah, I had surgery. Oh, we took out 90% of your meniscus. And I was like, oh no.
My dad had them both knees.
All both
Then it's
moved.
at least straight.
I feel like, no, he walks like this.
That'll be me. No, I'll be walking.
And he walks down the stairs and I'm like, get some new knees, right? And he's like, no, I'm fine.
These are great.
I'm fine. He's like walking down the stairs. I'm like, no, you're not.
I don't want to get surgery.
I don't have any pain.
Because they only last for like 15 years or something.
I think they.
You know why?
Yeah?
You know why he doesn't want them? Because he can't sit on the ground anymore with the kids.
With them.
Yeah. Because you can't bend your knee fully anymore.
And he can't. No.
Yeah. No, you can sit like this, but standing up then is like hard. So somebody told him, no, you can't sit on the floor anymore. You can't like bend the knees
So he's
properly.
just waiting until the kids are old enough that he doesn't. The crowd.
How did his knees get so bad?
Did he play
Like
soccer?
working in construction and playing soccer. Because he had like 3 times knee surgery on the meniscus. 2 times in one leg and 1 time in the other one. Even had to correct them at one time. It's like, okay, you're supposed to stop with your left leg. And
Please all rise.
Sean Kilroe. The degree committee here present has assessed the quality of your thesis and of your defense. In view of his positive verdict and taking into account your previous qualifications, the degree committee has decided to grant you the degree of doctor. Professor Van Loon is authorized to confer upon you this academic distinction in accordance with Dutch university custom. I invite your professor now to take the floor.
Please all rise.
Do you promise to work in accordance with the principles of scientific integrity at all times? To be careful and honest, transparent, independent, and responsible?
I promise.
Good, nice to hear. By the authority vested in us by law, and in conformity with the decision of the committee here present, I hereby confer upon you, Sean Paul Kilroe, the degree of doctor and grant you all rights attached by custom and law. As evidence of this, I now present you with the degree certificate signed by the rector, the secretary and the other members of the committee, and affixed with the official seal of the university. For the laudatio, I will hand over to your other supervisor, Professor Wall.
Thank you, Professor Van Loon. Thank you, Pro-Rector. Thank you, Examination Committee. The diligence and time that has been invested in this assessment is appreciated. Dr. Kilroe, I'll come back to you, but congratulations. Ladies and gentlemen of the audience, friends, family, and colleagues of Sean, your attendance is what makes the Dutch defence ceremony special and unique. It's a rite of passage that Sean will remember and a fine tradition into which he's now been inducted. You've all been involved in some large or small capacity in Sean's journey, and your efforts here are not trivial. And I, on behalf of the supervisory team, thank everybody for this. Looking back on Sean's academic career so far, on such an auspicious occasion as this, allowed me to ponder several aspects of his PhD journey. For those of you who do not know, a little context. Sean was appointed as a PhD student to be based at Exeter University, jointly supervised between Maastricht University by Professor Van Loon and myself at the University of Exeter. This agreement was struck as a mechanism by myself and Professor Van Loon, my previous postdoctoral mentor, to create an opportunity for a young scientist to support my career at Exeter and ultimately facilitate collaboration across the North Sea for the soon-to-become independent state of Great Britain. Sean did not know it, but he already started a year late due to the impossibility of two esteemed academic institutions finding it utterly impossible to agree on any kind of terms of a joint PhD. The outcome, somewhat predictably, was that both institutions were happy as long as they remained independent, and he actually undertook two PhDs. So this is actually the second of a double PhD of the same work submitted to two theses. So congratulations, Doctor. Technically, this did reserve the right for either institution or both to fail the award independently of the other. Of course, this result would be hoped not to be the case, and as we stand here today, it has not been. In theory, therefore, Sean had the best of both worlds, the young-ish, me, driven, new academic ready to support day-to-day in the lab, and the old-ish, wise professor sitting from afar, abroad in fact, offering words of wisdom from a successful career in science. And it's happy for me to say that Sean grasped that opportunity and worked across two different cultures in two different laboratories. As you've seen from today's defence, Sean undertook a series of challenging, invasive, and at times, as many people in this room can attest, all-consuming human studies. For the uninitiated, suffice it to say that these studies, while deeply rewarding, can take their toll and are not for those that lack resilience. For this work to be completed effectively, recruiting, executing studies of healthy volunteers who are voluntarily undergoing immobilization, blood and repeated blood sampling, potential claustrophobia of serial MRI scans and the rigors of analytical work, the work ultimately needs to be a labour of love. To do such research right, this is unequivocal, and a philosophy that I've shared both with Professor Van Loon, and I think that we can now say has been passed on to Sean Kilroe. I think this is something, aside from the PhD degree, the publications, etc., that Sean has gained that's less tangible, perhaps more profound. You can, of course, confirm with Sean over a beer later if he would concur with this assessment. As was exemplified by the final promise, this also results in myself and others will always have the deepest confidence in the data that Sean has produced now and in the future. So given that I've given a description to you so far of Sean's practical research, 7.5 litres of human blood collected, 15 litres of human saliva, 180 muscle biopsies. I know this is true because the government regulation of HTA keep hassling me for it ever since Sean has left. I think it is worth illustrating how far, in fact, he has come. I'll only offer a couple of brief examples of Sean earlier on in his career because it's not for me here to embarrass him on this inspicious day. However, for at least the first 6 months of his laboratory work, one of the early things that I had to instigate as a supervisor was a metaphorical swear box to cover his expletives in front of subjects. This had to be abandoned after 6 months, not due to his reformed professionalism and more appropriate command of the English language, but rather his monthly stipend was no longer sufficient to cover it. Second, but linked to the above, I will never forget gently suggesting to Sean that perhaps waving a naked blood sampling needle inches from the face of a participant, loudly exclaiming, "I don't know what the something I am doing," was not the optimal way for him to initially instill confidence in his research process. But of course, this changed. A technique we use in human physiology when repeated blood samples are required is to insert a catheter or a cannula into an elbow or a hand vein, and to prevent this clotting over a day, we regularly flush this by pushing sterile saline through. It has to be said that Sean's nerves were somewhat shattered when the first slightly knowing, slightly smug volunteer pretended to convulse at the first sign of a flush. Sean, I think, recovered from this. Fast forward a couple of years, and Sean found himself at the mercy of Professor Van Loon and his team. While one might expect he was greeted with typical warm Dutch hospitality, having accompanied him on his accommodation, though, I did have fun poking at the ideas that the somewhat suspicious Airbnb host might have in store for him at time outside the laboratory. That wasn't 2 examples, that were at least 4, so I shall move on. This brings us full circle, back to today, as I said, on this auspicious occasion. I'd like to bring my words to a close with a few final notes of gratitude. The examination team, while I'm not familiar with all the esteemed members of the committee, I remain in respect and admiration for the unrivaled history of metabolic physiology itself performed within Maastricht University, an institution that provides one of the several giants the shoulders of which our field still attempts to stand upon. External examiners, Professor Zintzas, Dr. Wittard, your individual entanglements with Sean over the years have only added to your appropriateness and your considerable expertise on the day. Thank you, and finally, well done, Sean. You made it here. You're not only doctor, but doctor, and all the best of luck now in the USA with your ongoing academic career. Well done.
Thanks.
I hand back to Mr. Pro-Rector.
Thank you very much. And, well, you said most of the things I wanted to say, so that makes it easy. Dear Dr. Kilroe, also on behalf of the Maastricht University, I congratulate you with the degree that you have acquired, and of course I congratulate your PhD supervisors with this very nice research, and congratulations to friends and family. I'm not sure if there's anybody online. Unfortunately, I think we still don't have the second supervisor online, but she has an explainable excuse, being a young mother right now. Let me not forget to thank our guests from abroad, from outside of the EU, but even the Brexit could not break the bonds between universities, between science, so that's very good that everything has happened. It's really a dual PhD because it's from 2 universities, Maastricht and Exeter. And again, we really appreciate you coming all the way to be present at the defense of the thesis here. Well, that said, I have some practical things. There will be a reception after this session, but we will make a picture with the whole team present here. So I'll just ask the audience to already go to the Refter, which is nearby for that reception, and then we will join you just a little bit later. And yeah, I don't see any view of the co-supervisor yet, so that's unfortunate. We will make one picture here, and then we go for the real official picture on the stairs of the university, and then we will join all the others for the reception. And I hereby close this session.